Our modern giants, the skyscrapers that pierce the clouds, the bridges that span vast chasms, and the massive dams that hold back the weight of entire rivers, are often hailed as the pinnacles of human achievement. Yet, there is a quiet, uncomfortable truth hidden within their foundations. Most of these structures are designed with an expiration date. They begin to fail, crack, and erode within 50 to 100 years. Concrete crumbles, steel reinforcements rust, and nature eventually reclaims what was borrowed. But if you travel to the heart of the Mediterranean, you will find a haunting exception to this rule of decay. 2,000 years ago, a civilization with no computers, no heavy machinery, and no modern chemical laboratories discovered a formula that defeated time itself. Roman concrete. It didn't just survive the elements, it grew stronger with every passing century, defying the crushing weight of history and the relentless salt of the sea. Today we are finally uncovering the secrets of this ancient engineering marvel, and the discovery is fundamentally changing everything we thought we knew about the future of our world. To understand why Roman structures still stand while ours fall, we must first look at the material that builds our modern world: Portland cement. Invented in the 19th century, it is the most consumed man-made material on Earth. It is a marvel of speed and efficiency. It sets fast, it's incredibly strong under pressure, and it allows us to build at an unprecedented scale. However, it has a fatal, inherent flaw. Because modern concrete is weak under tension, we reinforce it with a skeleton of steel bars. This creates a ticking time bomb. Concrete is naturally porous. Over time, water and air inevitably seep through microscopic cracks. When they reach the steel, it begins to rust. As steel oxidizes, it expands, creating internal pressure that eventually shatters the concrete from within. This is why our bridges crumble and our roads require constant, expensive repair. We build for the present, but the Romans built for eternity. When we look at the Pantheon in Rome, we are looking at an impossibility. It features the world's largest unreinforced concrete dome, a massive structure weighing 5,000 tons, standing perfectly for nearly 2 millennia, without a single piece of steel to hold it together. It has survived earthquakes, fires, and the slow grind of centuries. For a long time, the scientific world believed this longevity was a happy accident, perhaps the result of high-quality raw materials found only in Italy, or the sheer thickness of the walls. The famous Roman architect Vitruvius once wrote that Roman concrete formed a wall that was invincible, even against the hushing waves of the sea. But modern science has recently proven that it wasn't just luck or brute force, it was a sophisticated chemical masterstroke that we are only now beginning to replicate. The first part of this ancient secret lies deep within the earth. The Romans utilized a specific type of volcanic ash found near the town of Pozzuoli, known as pozzolana. This wasn't just any dirt, it was a reactive silica and alumina-rich powder formed in the fires of the earth. When the Romans mixed this ash with lime and water, it triggered a chemical reaction known as a pozzolanic reaction. Unlike modern cement, which creates a static, rigid bond that eventually becomes brittle, this reaction created a dynamic material. The Romans understood that by mimicking the processes of nature, they could create something that behaved more like a natural rock than a synthetic paste. This genius is most evident in Roman harbors and maritime structures. For decades, marine engineers were baffled by how Roman piers and breakwaters could sit in the corrosive, pounding salt water of the Mediterranean for 2,000 years without dissolving or cracking. In fact, many of these structures are harder today than they were on the day they were built. Recent microscopic analysis has revealed something incredible. When seawater enters the pores of Roman concrete, it doesn't destroy it. Instead, it reacts with the volcanic ash to crystallize a very rare mineral called aluminous tobermarite. These long, plate-like crystals grow within the cracks and voids, reinforcing the structure at a molecular level. Instead of destroying the concrete, the ocean actually turns it into a synthetic version of solid rock. The very environment that kills modern infrastructure is exactly what keeps Roman structures alive. But, as impressive as the chemistry of volcanic ash is, the most groundbreaking discovery came as recently as 2023, answering a question that had puzzled archaeologists for generations. For years, researchers noticed small, white, microscopic chunks of lime throughout Roman concrete samples. For a long time, these were dismissed as sloppy mixing, the result of ancient workers not doing their jobs properly. But a team of scientists from MIT looked closer. They realized these weren't accidents, they were the key to the concrete's immortality. The Romans used a process called hot mixing. By preparing the concrete at extreme temperatures using quicklime instead of slaked lime, they created a material where these white lime clasts remained as concentrated reservoirs of calcium. This gave the concrete a revolutionary built-in self-healing ability. When a crack begins to form in a Roman wall due to weather or seismic activity, water eventually reaches these lime clasts. The water dissolves the calcium, which then reacts with the volcanic ash and recrystallizes, literally filling the crack and sealing it before it can spread. In essence, Roman structures were designed to be living organisms that could heal their own wounds. While a crack in a modern building is the beginning of the end, a crack in a Roman building is simply a signal for the material to start repairing itself. This revelation is more than just a fascinating history lesson. It is a vital blueprint for the survival of our modern civilization. Today, the production of modern cement is an environmental disaster, responsible for nearly 8% of all global carbon emissions. We are trapped in a cycle of building, decaying, and rebuilding. If we can adapt the Roman formula of self-healing and mineral growth, we won't just build structures that last for millennia. We will drastically reduce our carbon footprint. Imagine a world where we don't have to replace bridges every 50 years. Imagine cities that grow stronger with age, requiring less repair, less replacement, and far less energy to maintain. By looking backward, we may have found the most sustainable technology for our future. The Roman Empire fell, its languages evolved into new tongues, and its legions vanished into the dust of history. The emperors who commissioned these works are long gone, their names often forgotten by the crowds that walk past their monuments, but their stones are still here, standing as silent sentinels of a forgotten brilliance. They whisper a powerful truth, that true durability is not just about being hard and unyielding, but about the art of adaptation, and the wisdom of working with nature rather than against it. We often think of progress as a straight line moving forward, but sometimes, the most advanced technology is the one we left behind in the ruins. To build the future of our civilization, to create something that truly lasts, we might first need to look deep into the shadows of the past and learn from the masters of the eternal city. Will the cities we build today still be standing 2,000 years from now? The answer may lie in the very dust and ash the Romans left behind.